Okay, right. So let me first draw the context. So we have, sorry, 1 second. There's a lot of dust that comes. So we are basically going to try to check the Ceva's theorem, kind of. Let us see. Have you come across this theorem in any text? Not yet. Okay, but you see, with any Euclidean geometry text or even Olympiad text, this will be there. Okay, but anyways, ABC. So can you tell me what was it about? What you understood? Perfect. And these three lines, if yes, provided that they are concurrent, right? So we have these three lines which are concurrent. Yeah. Okay. Hi, Pragadish. Yeah. So yes, so we have just started. We were just waiting. So we just started. So we are going to discuss the Ceva's theorem. Okay. Basically, when three lines that we are drawing here, as you can see from last time, when they are concurrent, then what can we say about the ratios? Okay. So if let me write it clearly. If AD, BE, and CF concurrent, then we can say something about the ratios, which you guys know, means I just stated it, and we have a feel for it, right? We have a feel for it that the ratios, the product of the ratios would be 1, because we kind of saw it in some special cases. Okay. Then, but let's write it clearly. So the rule, you see, the way I'm going with this is I'm just kind of going cyclically. Okay, like I'm taking BD, DC, CE, EA, right? AF, FP. Okay, you can also go in the reverse direction, obviously. That doesn't really change anything. So BD by DC, and then CE by EA, and then AF by FP. The claim is that this ratio is 1. Okay? Simply put, this is just a simple case. There are a lot of generalizations of this, but for now, simple case. Yeah. So what should we do? Should we try to prove this, or should we try to check this? What do you guys suggest? What were you thinking of, and what do you think we should do? Should we straight away go for a proof, or should we try to check it for some special cases? You can go for a proof. Okay. So we are not assuming anything about D, E, and F. Okay, except that they are all three are concurrent. Okay. So yeah. So how do we prove this kind of theorem? What do you guys think? Yeah, ratios with for example, like you want to compare BD by DC, something like that, or right. But how do we, yeah, right. How do we do that? That is the question. So the idea that is being suggested is that, okay, you look at this ratio BD, you look at this ratio BD by DC, and you try to compare it with, let's say, AE by EC. So let me write this. Let's see if this works. We'll see. There are maybe several ways to do this. Compare this with AE by AC. But how are we going to do that? What is a natural way to do that? And by the way, I'm just calling this ratio lambda, okay? You can call it anything, but just calling it a number. It's a number in the end. How do you do this comparison? So see, from what we have seen, if you want to compare BD by DC with what is there on AC, the most natural way is to draw a parallel from D. Parallel to what? Parallel to BE. Yeah, it is not surprising. Right? This is what we had done earlier also. Let's see. So let's call this D prime. So it's kind of like the shadow of D on AC, you know, if the light is being projected like this, whatever. Yeah. Now what? So now let's write. So we can say that ED prime by D prime C is also equal to lambda, right? Because you can just look at this triangle, right? Then this by this is same as this by this. That is for triangles. Okay. Pragadish, do you also see that? Because it's slightly from a different perspective. Okay, good. Nice. So then we move on. Okay. So now what do we do? So let us assume that, or let's call this lambda 1. So sorry about the notations maybe, but just you can just refer to, if you're confused, you can just refer to BD by DC. But just using those notations just to make things, you will see this will be helpful. Because just keep writing it again and again, it gets a little. And then let's call this CE by EA as maybe lambda 2. So now what can we say? So can we can we relate, sorry, can we relate lambda 2 and lambda 1?
Is it possible for them to be equal?
No, it might be in some cases, but in general, it will not be equal, I suppose. But it is definitely possible. But in general, they may not be. I mean, when it's a midpoint, you can see in that case. So let's see. So we can say maybe that AE by ED prime, can we figure out this ratio? Can you guys figure out this ratio, AE by AD prime, by using this two, this and yeah, I suppose that should be possible, right? So, so you do this. Now this is just some calculations, just solving some things. You see this 1 by lambda 1, right? Now we add a 1 because I don't want the D prime C, right? You guys see that. I don't want the D prime C, I just add a 1. I get this. So this is 1 plus lambda 1 by lambda. I've gotten rid of what I didn't want, right? The D prime C. Now you guys see how to find AE by ED prime. So remember you have this, you have this. But there will be lambda 2 also involved in it, right? Yes, there will be both lambda 2 and lambda 1 involved. So we can just divide, right? We can just divide this equation and this equation. Is that right? So you see, we will have this EA by CE, that is 1 by lambda 2. And there is this. And when you divide these two equations, yeah, you can just simple calculations. So, but I'm just doing it in front. So, okay. Sorry, so I didn't need to really do that, right? That was stupid. Don't need to do. I can just multiply these two, right? So take this, just multiply them. That's all, right? So you get 1 by lambda 1 by lambda 1 times lambda 2. Is everybody happy? Okay, nice. So you see, this is just calculation. This is just calculation. What I mean is, if I know, so if I have a line, just look at this. If I have a line and I have from this point to this point, now you see I have a point in it, okay? And let's say this is, let's use some different things. This is just a fundamental thing about ratios. It means you can calculate it. You can take numbers and try and do. If you know the ratio of xy by yz, and another point w comes in, and you also know yz by yw by, so if you know xy by yz, if you know this, and if you also know yw by wz, then you better be able to find xy by yw, right? Right? Yeah. So that is just basic thing about ratios, right? You should be able to find it, right? So you can just take some, so if you are not very comfortable, you can just take some numbers and try to do it, okay? But once again, I'll just say the way I have done it here. So you see, I had this ed prime by, sorry, one second. Yeah, I had this ed prime by d prime c. I didn't want the d prime c, so I just tried to got rid of it. And I just inverted the equation, added a 1, and I got rid of it. And then it's just simple calculations. You can do it in many ways. Maybe you'll take a longer turn, but you can do it. So should I move on?
Yes.
Okay. So you see, there has been no new idea. There has been no new idea, because the way we have approached this topic, the way you guys have struggled earlier, right, with drawing parallels and that trick we had, the same trick is working here. Apparently, let's see, we don't know. Okay, we are not using a new trick yet, and that's how I want to make things appear, and that's how we want to do things, that it should come as a limit of what we have done earlier, as a consequence. Anyways, let's see. So now you know AE by ED prime. So where now what should we do? Remember, in the end, you want to go to AF by FB. So just a second, I will keep. So you guys think, I'll just, conceptually you can think, what should you do now? This. And I'll just do some problems also, maybe. So we are doing this abstract thing, but we'll also do some problems after this. Let's do this. So, well, you have to do the same thing as you did on side AC, right? There is nothing special about AB, right? So, I mean, the most obvious thing to do, is to just do the same thing this side also. Is that right? Because there is really, if you don't do this, then why did we do that one, right? It's just strange. So it's just the most natural thing to do. So I'm just going to do. Yes. And so now what ratio should we try to find? So this is d double prime. Let me keep that also. So I found AE by ED prime. That was a new thing. Now we want to find AF by FD prime, right? And it's just the same calculations. It will be just the same calculations, right? So remember, CE by EA was lambda 2, right? So basically, I'm just trying to say it in such a way that, see, AE by CA was 1 by lambda 2. Okay. Right? Like top, bottom. Okay. AE by EC. CE. AE by CE was 1 by lambda 2. In the same way, we have to look this side, right? AF by FB is lambda 3. Okay. So in that sense, we have to take the ratio. So then in that sense, AF by FD prime should be what? Lambda 1 will remain lambda 1 everywhere, but lambda 2 will get replaced by not lambda 3. No, it will be 1 by lambda 3. क्योंकि lambda 3 जो है, lambda 3 is from AF, lambda 3 is in this direction, AF by FB, right? But lambda 2 was in the opposite direction, CE by AE. So you can see, but you don't have to take that risk. You can also just calculate and check, right? But you can feel it that, yeah, this looks decent. But either ways, I might still be wrong, but we can check it later if it's wrong. We'll know if it's wrong, but I think it's right. But the point is, you can find it and you can, there's no controversy in the end. Now what should we do? I'm also just thinking, because I've never done this proof like this. The proof that I know is a textbook proof, which is completely different. I know some other proof, but this proof I've never done. Okay, so I'm just doing this with you guys. So do you guys see I made a mistake? Okay, so Ishana, you are right. This will be lambda 3 only. So let me say the reason. So see, CE by EA was from bottom up, right? AF by FB, AF by FB is from top to bottom. So that is opposite. Okay. You may think that lambda 2 then should not be replaced by lambda 3, but you see, BD by DC is also getting adjusted, right? BD by DC was from this, but in this one, it is from bottom to top, right? So what I'm saying is BD by DC is equal to BD prime by, sorry, by, yeah, BD, oh, it was right, D prime F, right? It is from this vertex up, but in that case, it was from ED prime to D prime C. right? But you can still do the calculations and check. Actually, let's do one thing. Let's actually calculate and check, right? This is too much hand waving. Uh, let's do the calculations, but it should be right because that's how beautifully the notations are set, right? That it just works out in the right way, but we should know it from calculations because we should not be so advanced without understanding. Because I think even I might not understanding what I'm saying. Let's calculate it. So we know that AF by FP. You guys also do the calculations. That FT prime is equal to PT by DC. That is lambda 1. That is PT by DC. Yeah. This. Yeah, even lambda, I think lambda 1 will get replaced by 1 by lambda 1. Let's see. So VD V double prime plus, sorry, try D prime F F D double prime. This is equal to this one. So BF F by D double prime is lambda 1 plus 1. Yeah, and I can use this and I can use this and I can multiply them. Right. So I get AF by FT double prime is good or wrong? It was wrong. What we did was wrong. This is the correct answer. Okay. Do it, check it. I want you guys to do this yourselves. Okay. If you cannot do yourself, then try to then see and ask me. Okay. Pragadish, do you, yeah. Is it coming out to be the same or or is it, are you okay with the calculations or do you want me to say it again, or if you have something to ask?
Yeah, I'm a little confused.
Let's do it. So well, let's do one thing. Let's actually do this for a straight line, just in a general case, right? Because this is a general ratio proportion type question, right? In the geometrical case, let's try to understand this clearly, because I used to get confused for a long time with this, very long time, even last year when I was thinking about this, getting confused. So yeah, so the situation is that you have 4 points. Okay, let's say that there is x, because I want you to understand this in general, like in this nice sense, x, y, z. So suppose you know that xy by yw is 3 by 2. Suppose you know this. Okay, and then yw is further divided by z. Suppose I also told you that yz by zw is equal to 5 by 2. Okay, now my question is, how would you go about finding xy by yz? First of all, you should try to see, is it possible to find, and try to find. Yeah, just a second. So if any one of you can do this, tell me the entire procedure also, then we can move. Just create space here. You're getting xy by zw. Okay, so how much are you getting and how are you getting? That is more important. Okay. Uh, Plus 1. Okay, so right. So 1 second. Right. So Pragadish, do you see the strategy? So it's kind of getting like this ratio, that is yz by zw. We're trying to combine it and get yw in the picture maybe somehow. Right. Yeah, because we want to have xy, we want to find xy. I mean, we want to have xy in the ratio that we want to find, but we do not want z. We do not want yz. Right. We do not want yz. Is that right? You see, we do not want yz. Right.
Yeah, why we don't?
Yes, because yeah, right. When you do +1, then the yz plus zw, you combine that line, right? So you do yz and plus zw, right? So yz and zw add up. Is that right? Okay, when you do +1, this is what happens, right? And this is the thing, because when you do that, then you get rid of yz, right? You get yw. That's the thing about lines, right? And then you get 7/2. Yeah. Yes. Okay. Now all you need to know, you have this equation, you just need to multiply them, right? Because that's how you'll get rid of the yw.
Well, wouldn't it be that depend?
Which two equations are you saying?
The equation
No, it's not 2w, it is z. Oh, that is the problem. The problem is the z and the w. No, there is no 2. So how would the 2 come? Okay, I agree that my handwriting. Okay. Right. No. So which ZW cancels out? In this or
Yeah.
no? No. So we don't want to cancel it out. You see, the reason why we have added a 1, the reason why we have added a 1 is to get YW. Right. So then why would we want to cancel it out, right? We want to add it up. We want to add up YZ and ZW. To get YW. All right. And how would you cancel it out? If you, I mean, you can't simply do this. Yeah. Right. So that's the thing. And then we get this. And now you have the YW by ZW and you have XY by YW. Let's multiply these two equations. Right. The YW will go away. Right. So you have this XY by YW. Right. You just multiply this with YW by ZW. Right. Then this cancels out and you get XY by ZW. So is that okay? Yes, okay. But is this okay? Yeah, okay. So Pragadish, is it okay for you also? XY by ZW is 21 by 4. Or is there okay? Then it's good. Now you guys try to find XY by YZ. Let's see. If you guys have really understood this, then you should be able to find XY by YZ also. So I'm not going to say it. You take your time, you guys take your time and figure out XY by YZ. See, you can do this in many other ways also. You can maybe take one of the lengths to be 1. There's no harm, right? You can say that I'll take XY to be 1. Nobody is stopping you. It's not wrong. It's okay to do that, right? You can do that. You can do anything you want, but in the end, you have to find them. XY by YZ. So find me XY by YZ now. So think you have to not get rid of YZ, but something else. Let's see. So yeah, you guys may not done this kind of questions earlier. That's why otherwise it's not difficult. Okay, this time you're getting 21 by 10. Okay, so we'll just wait. Let's see. Let's see how what Pragadish is getting. Then we can match it, or we'll see. Yeah, these kind of questions maybe are not done in ratios in the standard thing usually. No problem. This is, there are many interesting things in ratios actually. And meanwhile, Ishana, you can think of why are we able to find XY by YZ? Okay, you have found it, but why are we able to eventually find it? Even without finding the answer, would you know from before that it was possible to find it? Think about that. That's a very crucial question, because now if I give you many points and I tell you many ratios, and then I ask you, is it possible to find the ratio of this by this in the end, or something like that? So think here only, why is it possible to find XY by YZ? So that is an important thing to know. Calculation comes later sometimes. Yes, I think that's a good reason. Yeah, right. Yeah, basically we know how much is YW compared to XY, but then we know how much is YZ compared to YW, right? And so we know how much is YZ compared to YW, but we know how much is YW compared to XY. So we should know how much is YZ compared to XY. In ratio sense or any other sense, you can say. So yeah, that's a good reason. It's very crucial to know because sometimes you'll have some strange things and you will not be able to find the ratio, but you should at least know that there is a ratio. And then you can use some other techniques to find it using some easier techniques if you know that it is findable. Right. So Pragdish, are you still having any problems? I think that then I'll try to do this in a different way.
Now but I'm not exactly sure the essence of my text is right in second.
Oh, no, no. Yeah, if you like, no. So what I'm saying is that whatever this would have been and whatever this would have been, you can find xy by yz in terms of that, in terms of those two things. I mean, whether the exact number is given or some alphabet is given, that is not really a problem, right? You can just do the same thing that you did for these numbers, right? So are you able to find this for these numbers? That are you getting 21 by 10? Then it's cool, yeah. So then you can just run the same procedure if even if there were no numbers. In fact, it's much easier if there are no numbers, right? You can just use the symbols. Right? Just do the same things and just do whatever you did to these numbers, just do them to the symbols. Okay, and you would get some. In fact, you will get some formula in terms of lambda 1 and lambda 2, right? So that is something that you can just. It's the same thing. What you did for numbers is do them for the symbols. So the point is that if you do that, then you are going to get AF by FD. No, AE by, so first of all, AE by ED prime. Let's come to this problem. Okay, so in this problem, you can see so once we do this question and we know how to do this one, then we can find these ratios in this question also, right? Because see, AE by EC, okay, that is given, right? 1 by lambda 2. And then this ratio ED prime by D prime C is also given. That is BD by DC. That is lambda 1. Okay. Now, Pragadish, because we have not done this calculation, do this for homework. Try to then show that AE by ED prime is equal to this. Okay. Yeah, because see, it is the same question in some sense, right? It is just that I tell you here. So you can place the A and you place the E, right? In fact, after some time, you don't have to do this like this. You can do it directly, but if you are more comfortable like this, you can do it, right? You have this thing, right? And then you know that AE by C, okay, I know AE by C 1 by lambda 2, right? And then you know that ED prime by D prime C also, you know, is equal to lambda 1, right? So then these are the same questions, right? To find AE by ED prime, you can just do the same procedure. Okay, yeah. So just do that and you will get this. Okay, so I'm erasing this. So break it down, write it on a horizontal line if you need to. I suppose both of you can do this again. It's a good exercise because soon we'll be doing some more complicated ratios, but it's fine. We get this, and then the same way, AF by FD prime also comes out to be this. Okay, I'm not doing the calculations again. There's no point. You have to, once you do it yourself, if you can do yourself, then only it counts. So you should try to do this, but you know how to do it, but you should do it and check. And then if you get confused, you can ask me. So now that you know these two things, how are you going to use these two things? Let's write that. So this is a rather big theorem at this level, right? So we are kind of trying to prove it. So we have this. And then we have AF by FD prime. FD double prime is this. So now don't think about how this came. Okay, both of you, otherwise it's confusing. Just say if you have these two things. Now, how can you use this? Now, that is the key. You guys will see how similar this is to the problem that we did earlier. We had drawn these parallel lines and so on. Where that time FE was parallel to BC also. So remember, remember that what you need to show is lambda 1 times lambda 2 times lambda 3 is 1. That's all you need to show. That is the exact question. Okay. No, yeah, you can say someone. Yeah, okay. So if you see, do that, yes. So we can obviously divide these ratios. There is a divide or okay, wait. So AE by ED prime is this, and AF by FD double prime is this. Yeah, so let's divide them. If you divide them, then you get this. Yeah, right. So it makes sense to divide them. Okay, I see that now. Okay, I get it. That's why you're dividing, because then you'll, right. So when you divide these two things, you can check, you just get. You want to show it is 1. Right? So do you guys see this? We want to show that this is 1. Okay. That is the same as saying that we want to show that, we just show that this is 1. Look at the figure. You want to show this is 1. Now look at the figure with this version. You want to show that this is 1, but this is equal to this. You want to show this is equal to this. Can you see that in the figure, why they are equal? Right? Because AE by ED prime is equal to AP by PD. That's the connecting line, right? This AP by PB is a connection because they are both equal to AP by PD. And this was the exact thing we had done in that problem also, kind of, or maybe we did a simpler method later. Okay. So AE by ED prime is AP by PD, but then AF by FD prime is also AP by PD. That's it. Both are equal. And so that is what it is. So you didn't, so one doesn't have to even divide this, right? Because one knows that AE by ED prime is AP by PD, right? And this is also AP by PD. And so they are equal. These two are equal. And then you can cancel them. You get. So take this, go over this just a minute, okay? And see if you have any questions. Modulo what I've given for homework, the other ideas, go over it from the beginning. First step of drawing parallels, comparing the ratios, see. There is no new idea. That is, I think, the best part. Well, best part in the sense we are able to do this from what we already know with a little bit of ratio thing calculations. Yeah, please tell me if there's any part you want me to say again. You should tell me. Okay, Pragadish, is it clear to you also? Okay, so the ratio things, you guys check it again, how to find those ratios we have found. And then finally, you can see it is just the same thing that we had done earlier, where FE was parallel to BC, right? This time it is not, but the same technique works. Okay. Now, I have seen this theorem in dozens of books, but I've never seen this proof. Okay. Every time there is a different kind of proof given, which is cool, but it is a little tricky. But this is a proof that I didn't do, right? So Ishana told me the idea that you try to take BD by DC and you put it on, somehow compare it with AE by EC. And we know how to do that. We have said that several times, that you do draw parallel lines. That's how you project the ratio there. And then you do this side. And then we combined and some fun we got there. Okay. You see, it suggests that we knew the earlier thing, we struggled with it and did it properly in the simpler case where it was not hopeless. And now we used it here. I find this very interesting. That's the good thing about maths. Okay. So you can fill in the details. Please fill in the ratios, do the calculations again. Yeah. So now we can safely say that we can remove these things. Now there are several of the interpretations, but let's not go into more and more interpretations. I'll not go into them now. Several interesting ways to see this. But those should come naturally, right? If I just say one thing after the other, it is not so good. So we can safely say that if these three are concurrent, yeah, this is thing. So if, okay, let me write that again, no problem. Okay, if AD, BE, and FC are concurrent at P, then BD by DC times CE by EA times AF by FP is equal to 1. This is the wonderful theorem. One second. Yeah, so it's good, right? Let me just try to do a very small question from here. Okay, so if area of ABC, the whole triangle, the triangle's whole area, if that area is 1, okay, and area of ABD is 3 by 4. Area of ABD is 3 by 4. Okay. And if area of BEC is half, okay, then I want to find area. Now, this looks like an area question, but let's see how you guys do it. Find the area of AFC. And I just come in a minute. Just close the door. Okay, so what do you guys get? So any ideas? No ideas? Nothing? Anything? Yeah, anyone? So are you guys not getting any ideas?
I tried to put labels on stuff.
Okay. Okay, no problem. This is a new, different kind of problem. Kind of made it up just now. Okay. Pragdish, are you getting anything? Otherwise, then I'll give some hints. You can see how to. Okay, okay. So see, the entire thing is about areas, right? So you can see that it is not like those questions earlier where, is you could take some piece, add some piece, and make that piece what you want, right? Because you see, we are looking for this AFC, okay? But the things that we are given is like, so see, you are given ABD, it means that you are also given ADC. Maybe you could do it like this as well. I don't know. You're given, you can, so you know ADC, how much is the ADC? 1/4. And so does that give any idea? So ADC is 1/4. So you already know one ADC. All you need, if you just think like that, like in a reductionist sense, you need AFP. Okay. The BEC, remember BEC is also half. BC is half, which means that this other piece that is ABE, this is also half. Yeah. Yeah. But then you don't really know how much is the overlap. Right. Yeah. Right. That is that seems to be the problem. Okay. Yeah, because I'm not given AFC. Okay. But can you guys find APE, or can you find APC? Yeah, can you guys find APC? Just asking a different, slightly it's connected. Can you find APC? I don't even know if it's possible. Just no. Why? APC is different, right? It will not be the same. Yeah, base you could take that base, right? So I think it just gets a little tough like this. So let me tell you the kind of solution I had in mind. Okay. Because I want this to not go in a different direction. I want to just show that it is an application of what we've done. There are other ways to do this. If you put labels, X, A, X, Y, Z, W, whatnot, you can try to relate them because you know the ratios. But the point is that why are you guys not relating the area with the ratios? Right? If you know ABD, so let's forget about what you know. You need to find AFC, right? You need to find AFC. What does that mean? It just means you need to find AF by FB, right? Or AF by AB, all those are same things, right? But you see, I'm just putting this here, so that's okay, right? BFC, BCF, whatever, right? BFC. I'm just putting this, but that's not a problem, right? You know that AFC, if I need to know AF by FB or AF by AB. So then why don't you, because the theorem we just did now is in terms of ratios. So why don't you try to use ratios, right? So AF by FB, we need this, okay? But do we know the other ratios? You know what I mean by other ratios? Do we know BD by DC? It's 3:1, right? Because you can just, it's just ABD by ADC, right? So from the areas, you get the ratios, right? Yeah. So is this okay, Pragadish? Is this okay with you? This ratio of the bases is the same as the ratio of, this is another idea which we have used here. Yeah? This is the idea we are using in some cases. This is a very fundamental thing, right? Triangles with the same base and kind of same base mean the same baseline, and same height. And the ratio of the bases. So this is just 3. So if you know BD by DC, and then you also know, so what is AE by EC? Or CE by EA, I should say, but yeah. This, no, AE by EC. Why? So just think, take your time. It's just 1:1, right? Pragadish, do you see that? It's just 1:1, right? Because it is just, right? It is just this AE by EC is just the area of ABE by BEC. Again, when you're talking about this ratio, you look at the corresponding triangle like this, right? That's ABE and BEC. This way, because this is the P is the common height. Okay, so this is going to be 1. Now you should know how to find AF by FB. That is what we have here, right? Simple. So what is AF by FB? Basically, what is coming out to be? Yeah, just put them in. Just put them in the machine, right? And you get the answer. So BD by DC is 3, and this is 1, and so AF by FB should be 1/3 to balance things and make it concurrent. Yeah, that's all. So it's just 1/3. 1/3. That's all. So it is 1/3. It's 1/3. So now you tell me what should be area of AFC. So AFC, the area of AFC by the area of BFC, that's 1/3. It should be 1/4 of the whole thing, right? And so that is easy. So let's just finish it though. Let's write it clearly. So this is BFC, and if you have BFC, but you have to use ABC, so you just add BF. You add another BFC maybe. No, you add AFC. Sorry, because you need the ABC, right? So you add. That is just you add AFC, right? And this becomes 4 times. It's just you can find. So it's 1/4, right? So this is ABC. You can just basically you can find this. You can see it's 1/4. So AFC is going to be 1/4 of the whole triangle, but it is then just 1/4 because the whole triangle is 1. It just basically in the end of the day, just find the ratio AF by FB. Once you know the ratio AF by FB, then you know AF by AB, and so you know what is AFC compared to the whole triangle. Okay. So ratios are intimately connected with areas. Okay, we have been just using them back and forth. Okay, this also we did earlier some problems, right? We had to find area. We reduce the problem to finding ratios of the corresponding bases, and we found them by drawing parallel lines. But now we don't have to do so much work all the time because we have kind of done the work of finding parallel lines, and we have made a theorem out of it. We have done that work once. We've made a software. Now you can use it. Okay, so you don't have to always draw those parallel lines and think again and again. Okay. Obviously, now you'll have other things to think because the problems will get more complicated, right? But this part is you don't have to think. Okay. So, well, now the task is, as is homework, find the ratio, find the area of each of those each of the 6 triangles. Okay, this is the homework. I think it's an interesting question. So find in the same thing. Okay, same problem. So find the area of each of the 6 triangles, the small triangles, I mean. Okay, so try this problem again yourself, see how I'm doing it. You can see it later, or you just note it down, key things, and try this again. Yeah. I plan to do other things, but I think we should stop, right? This we did. So today we kind of did a cool proof of Ceva's theorem, and we did a very small application. Okay. So you can guys tell me how you're finding this topic. If you want me to change some things. Okay. So my idea is to keep a balance between theory and problems, and just take the theory also as like when we do the theorem, I don't want to just state the theorem and start giving the proof. There's no point. Okay. The theorem, the proof of the theorem itself is small problems basically. And I'm trying to lay the topics in such a way that you're prepared for the next topic with a little bit of new idea, and then for the next with a little bit of try to connect it back and forth. And till now you can see, right, that everything is kind of connected, right? I'm trying to do this in that way. Okay, so that everything is connected, but arrange things in a way that so that it is connected, highlight the points, the connecting points. And then we're doing these small problems too. Okay. So try the other problems that I'd given. Just try this one more problem I'm giving. Yeah, and go over the things if you need to, and ask me questions next time. Make suggestions if you want me to do few more examples, less theorems, or if you feel we should do more theorems, I'll take your suggestions. There are only 2 of you right now, so it's good, right? So basically I have this question. This is, and by the way, if you want to practice this, any basic Olympiad book will have. Okay, but for now you can try that. I've given enough problems which you can try, but other than that you can certainly look at. So for easy problems, yeah, that is the point. All the books say, no, just try the problems I've given. Otherwise you're trying papers and mocks and so on. So that's, yeah, for now just. But even if you just type in Ceva's theorem, maybe brilliant.org, they have a page, right? You can read the part if you want, but most importantly, they have problems. And there is first you'll get some simple problems to begin with. You can just try them, some simple calculation, because now you know the theorem. So you can begin trying them. Okay. The harder ones you will not be able to do maybe because they're more geometry you need to know. It's the surprising results. They're not so surprising later, but eventually, okay, you can try them. And certainly there are other books, but for now you can do these problems. These are, I think, enough. For now, you can tell me, you can let me know. So I was just, while you guys were thinking, I was just making another problem up. This is just not, this is exercise. No, these are not problems. I cannot make problems. They are difficult to make. I cannot make them so fast. So what is basically happening is that this is the wrong way to do it, first of all. So what I did was I just made first you make a concurrency. Then you make the, you can see geometry is very interesting because you can see things, and so you can do a lot of maths, in geometry without knowing a lot of terms and so on. That's the beauty of geometry, Euclidean geometry. So I have made one side, this green thing is parallel, but the others are not parallel. So I'm just highlighting that thing. You can see they are not parallel. Okay. Yeah. So I should also do something here, which I forgot to do. We'll have to extend these lines. By the way, the last day's problems where I said to check this result for simple things, like maybe you can check it for medians, altitudes, do that also, but they come first. Those problems come before these problems. And yeah, then you can put notations, you can put anything, X, Y, Z, and you know, D, E, F. And I've already given enough problems, but just this is a problem that's made up. So try this. G, H, I. Okay. So now let's say that I told you that BD by DC is, let's say it's just half. Let's say it's 1. Okay, BD by DC is 1. Yeah. And let's say that YH by HZ is, how much does it look like? Maybe 8 by 7, right? 8 by 7. Okay. Now I want you to find, this is actually not very difficult, but we'll see, no problems. So remember this is X. So this is X here, this is Y. XI by, have I, yes, I've used wrong notation earlier. So this is XH by HZ. And then I have XI by IY. Okay, this is what you have to find. Okay, and remember we are given that YZ is parallel. So I've carefully thought of what we have already done. I've combined them to make this problem. So let's see. Please take a time and think about this. Note it down if you want to know. You can see this later, but just note it down now. It's always better. Okay. I want to share one more problem. Very similar situation. Very similar situation. So just random things, lines. Now, if this red line is parallel to this black line, okay, and if this pink line is again parallel to this thing, okay, this is maybe very simple. You'll try. Then I want you to show that so if any two of them are parallel to the corresponding things, I want you to show that the third one is also parallel. It looks pretty obvious. Looks obvious. You have to see how you do it. This will be rather simple, I think. Yeah. Okay. So do I need to write it? So this is D, E, F. Okay. So if I'm saying that if DE is parallel to AB, but this is something that you know that it should be true. Right? It should not be not true. Okay, but how do you prove it is the question. And if BF is parallel to BF, yeah, BC. If BC is parallel to EF, I mean any two of them parallel, then that that implies show that, right? You can write show that DF is parallel to AC. Okay, so you can try this problem. This is a fun problem. So when you're done noting it down, tell me I'll just give you one more problem which is related to all this. You can note it down, you can take pictures. These days you can do anything. Or you can. Okay. Now I'm just going to erase this. Okay. All right. So this is simple. Now I am erasing this. Okay. So now you see the fun. Now if I tell you, so I'm going to erase this. Now if so, you should always see if I'm doing something or saying something, you can always interrupt me and ask. Okay. Don't be just sit and okay. If anyone of you think, just interrupt me and say no. Wait. Okay. So if DE is parallel to AB and BC is parallel to EF, and if so this kind of question you may have never done before, but this is very simple. We'll see when you can do it or not. And if this is true, then show the last problem is kind of already prepares you for this. Then show that AD, BE, and FC are concurrent. And again, you can kind of take two parallel triangles, right? If you take two parallel triangles and you join the vertices correspondingly, then they meet at a point. Now that again is something that should be true, right? How can it not be true? But you have to prove it. Nice. Okay. So, okay, now I'll just wait for 5 minutes. I'll be here. Any questions, anything, ask me, tell me. Then otherwise you can leave. Okay. So you can note down, think, go over. I'll just wait, sit here for some time. Okay, then. So if you're done, you can. Okay, there are no questions. Okay, so you're also done. Okay, then no questions. Then good, good. Then try these. Please try this. Okay. Thank you. Bye.